Hello. It's nice to see you all here. So yeah, I'm Martin Vrachev. I work in VMware and their open source technology center. And I am a security developer there. And today we will speak about next level static code analysis, reporting in next level fashion. But first, it's good to define what is a static code analysis to understand how they can help us to see the different categories we have and to see that they could be a little more complicated too than we initially thought. When many people, when they hear static code analysis, they only hear and understand style guidelines and annoying warnings about spaces and double quotes or single quotes. But today I want to show you that they could be more than that, and then they can really help us in the modern development. Also, we will see that they have limitations because the tools I will present about, and I will show you today, are command line interface tools, or basically local tools. They're really great for local development, but are not so great. Not so great for a maintainer. So we will see what can we do about the maintainers and how they can enforce static code analysis upon their open source projects. All of the tools I will present today are open sourced, and I will focus more on how we can build good projects in the open source ecosystem. And finally, I will first show the limitations, and I will give you some solutions on those problems. So first, what is a static code analysis tool? Those are tools which are focused to scan your code for common mistakes. Something really important about them is that they don't need to run your code. They don't need to have the full functionality. There are different tools which are called deep static code analysis or the dynamic code analysis, which is a little more different. And they're not. They are aiming to help you they aim to help you to write better code on syntax level. But as we will see in the slides which are coming, not only on syntax level, but there is a little more complicated semantic which you can add to them. Also, something really interesting is that they're using abstract syntax trees. Those are structures which are used from compilers and interpreters to do their job and optimize your code, but also really helpful for static code analysis. So some great examples are PyLint for Python, ESLint maybe some of you know for JavaScript, GoLint for Go, and Go check style for Java. There are a lot of them. Some really famous proprietary tools are like Fortify, maybe you've heard of it, maybe you haven't. So first I want to describe the basic functionality of a lint. I will call them linters for short, because I will mention that word a lot. So normally, linters are really useful to enforce style guidelines. That they're famous for that, and when you have a big company and you want to enforce a style upon your whole code base, they're really useful for that. So we can see in this example, you're missing a space or you're using double quotes. That is considered a problem. We all know, maybe most of you know about those kind of tools. But also something really interesting is that they could be really useful about finding common stupid bugs we all do in our code. Like for example, in JavaScript, if you make a verification using only two assignment operators, that could lead to unexpected circumstances. The reason is that the array with index I can be casted to a value of 0. And let's say if that's a Boolean variable, which is false, you can go into the if statement without even noticing it. Another mistake that I think all of us have done is to do an assignment in the if statement, which is, again, a stupid mistake, but they could be useful to help you find those kind of mistakes. Okay, so we have style. They're really useful for style enforcement. They're really useful to find common bugs. But let me show you what are the next level linters I mentioned you about. They're focused on security rules. They're focused to help you find small and common security vulnerabilities. So they could be separate linters. And when I mention separate linters, we have GoSec for Go. Bandit is a really famous one for Python. Or you can have Flow Finder for C and C++. Or you can have plugins and modules with the security rules. And one good example for this is Podbugs. So we speak about vulnerabilities, but it's really important to know what kind of vulnerabilities those tools can mitigate. So first, and maybe you know that one a lot. You have seen it. Leaked credentials is a problem everywhere. If you do a simple search on the GitHub search engine, and when you write a password, you can see a lot of results. And I'm sure that even with a simple eye, you can understand that most of them are leaked credentials. So we know, and because I have contributed to security linters, and while I was contributing there, I knew that hard-coded passwords can lead to a lot of false positives. So that's a known problem. And the idea is, how can you prevent that? Many of the modern tools are using the so-called Shannon entropy measurement. This measurement gives you the diversity of a string. And when you combine Shannon entropy measurements plus the length of the string, you can have a good idea if the string is hashed, encrypted, or it's just hard-coded by a developer. So it gives you a little bit more confidence when you report hard-coded passwords to the user that there is actually a problem. Another really cool feature is that those tools can tell you about weak cryptography algorithms and keys that you're using. The cool part about this is that the tools have a big confidence when they report mistakes of those kinds. And why is that? And why is like that? The reason for that is it makes a really simple check. It knows that if you're using SHA-1 or MD5 or MD4 cryptographic algorithms, they're vulnerable for more than 10 and 15 years. So basically, if you're using them with a little more computational power, somebody can steal your passwords. Another notable example is if you're using the RSA algorithm with a key size of under 1024 bits. There is a problem in this, and it's well known that you have to use key sizes with 2048 bits or above. And if you're using a lower keys, you can have a big problem. And third notable example is when you're doing SQL queries, you can have a lot of SQL injections. And here the problem is big. If you search in the OWASP top 10, I'm sure that you can find a lot of cases of SQL injections from all years. I think there were a lot of cases in 2018, 2017, and going back in time, you can find a lot of vulnerabilities. And there are a lot of other vulnerabilities I won't speak about. Sorry. But I wanted to mention something really cool, is that those tools can have rules which are really specific. For example, Bandit has a rule which will warn you if you're using YAML.load function from the PyYAML library. And that's a really cool feature because YAML.load gives an attacker an arbitrary code execution if he knows what file to give to the function. So it could be really dangerous, and if you create specific rules for specific vulnerabilities, those linters could be really useful. So that's really awesome. But as I mentioned, those are command line tools. So the next logical question is, if I'm a maintainer of a project, how I can use them? And of course, we can do that. We can clone the repository and we can run those linters locally. But most of the times, you're not a single maintainer. There are a bunch of maintainers with you, and they will want to have the same confidence, and they will have to do the same steps. And then, that's the work you're doing. It doesn't make sense. So that solves only half of the problem, and there should be another solution. And actually, there is. So the next step, logical step, is to use the continuous integration tools we're already using. In the open source ecosystem, many of the projects are using Travis CI or Circle CI. So what are the preconditions? First, of course, you have to create a script which will run your linter. That's not a complicated job. Let's say we know how to do it. Then, of course, you have to know how to use that tool and to make it to run that script. Again, that is not such a big problem. But the biggest problem comes when you have to read the output. And I know that there are CI tools which gives you a beautiful UI, but many of them are not like that. And Travis CI is a popular open source tool. And let me show you an example of the output. I know you can't read it, and those are only 30 lines. The exact number of lines the total number of lines for that concrete build is 2,600 lines of logs. And there you have tests. There you have other checks. There you can have a lot of different things which are bundled together. And now let's imagine that you're putting your linter there. So you have different reasons why your build can fail. And I feel that this is not the perfect place where you should put your security checks. So let's see where the problem's here. And it's really hard to spot those 3 lines. I know that it's really hard even now that you're not in front of the computer. But I will show another solution. Precaution is a GitHub solution. It's a GitHub application which is free to use. It scans every single new pull request for security vulnerabilities using the security linters I mentioned to you about. So it uses Bandit, GoSec, and a tool for JavaScript and TypeScript. Currently, those are the languages we're supporting, but we want to extend it with more. It has a nice output, and there is a way to handle false positives, because as every automated tool, there will be false positives. So, what I mean that every new change will be analyzed. So this is your normal pull request. In your pull request view, there is that section, there is the precaution section. And something really neat is that you can make it as a mandatory check. That means that if there are issues, precaution will stop the commits from merging into the master branch. Another cool thing is that, okay, you saw that you have problems. Let's see what are the problems. There is a summary view where you will see how many errors and how many warnings there are. And here, if you're interested more about the vulnerabilities, you can click on the title of the issue, and you'll go to the documentation of that concrete issue, and you can read more about it. That's great, but we don't have the context of the code. Maybe it will be really cool if we can look at the code and look the vulnerabilities at the same time. And we can do it. You can go to the Files Change tab, and you will see precaution output underneath the exact problematic code line, which is really useful to understand what is the problem, and you can discuss this with your colleagues. Okay, so I mentioned that we expect that there will be false positive. That tool is an automated tool. It's not perfect. What can we do about this? So because we're using 3 different tools for the different languages, we have to do it a little differently for every single language. The problem is that there is no UI feature in GitHub to do it, directly into the GitHub ecosystem. So in Python, what you should do is when you have a problem on the left picture, you can see we have a problem. We are changing the permission to the etc password file. We can just put a no-sec comment, and that will be ignored from precaution. Same thing applies when you have problems in Golang. But also you have that addition that you can add a special comment which will exclude a whole block. And for JavaScript, the TypeScript is the same. The comment is a little different. So that's awesome, but what about our test files? So we know that we want to check our main source files. but we have test files where we want to do everything, and we know that those files won't be executed in production. So there are no vulnerabilities there. Well, there is a way to exclude files from scanning, and one way is to specify a specific file to be excluded. Another useful way is to exclude files by an extension. For an example, I gave that example. In Golang, every single test file finishes with test.go. And you can give that pattern to the precaution YAML file, and precaution will ignore all those files. Also, okay, but we have our dependency folder. Well, you can exclude all files from the dependency folder as well. And the syntax we are using is a normal, standardized glob syntax. You can read more about globs if you're not sure about it, or we can discuss after that. Okay, so I will just start a small demo right now. So here, what I'm doing, I will create my commits with drag and drop, which is the easiest way to do it on a demo. And then I will create my branch. And when I create my branch, GitHub will ask me if I want to create a new pull request, which I will do. And after my pull request is processed, I will see that precaution has started. But it shows that I have issues, and it will be really cool to see what are those issues. So I go to checks tab. I see the summary and the problems, and I could look the description of the summaries below. And now, if I want to see those vulnerabilities into the context of my source code, again, as I mentioned, I could go to the files change tab. And I will see that I have SQL injection. Also, I'm using a number generator, which is not cryptography strong. And I am importing bad libraries and so on. And so I see a vulnerability. I don't understand it. So I will go back to the checks tab, and I will go to read more from the documentation. And I can do that just by clicking on this link. And I can understand why this is a specific problem. So that's awesome. That's really cool. But Precaution is on GitHub. And I realized that not all open source projects are on GitHub. There are projects on GitLab, there are projects on Bitbucket, there are projects everywhere. So I will discuss about tools which are on GitLab, and then I will mention a tool on GitHub. So static application security testing, or I will call it SAS, is an official GitLab feature. This feature is free for all open source projects. But if you wanted to use it in your GitLab instance, you can configure it, but you have to speak with the GitLab support. It scans your code for security vulnerabilities. It's something really interesting is that it scans your whole project every single time. It's really cool that it has multiple configuration options, and it supports 14 languages, which I think is really impressive. So I mentioned to you that every single time, your whole project will be analyzed from the SAS tool. What I mean by that is when you merge a commit into the master branch, it will be created a new pipeline, and in this pipeline, there will be the so-called SAS job. And in this SAS job, you will see the security results. I will show you after a minute. So that's awesome. But as I mentioned before, Precaution scans pull request. When you have a pull request, Precaution scans the diff files. What is SAS doing? When you have a merge request on GitLab, SAS scans the whole branch. It scans the diff files with all of the remaining files. So every single time, it scans the whole repository. And what is the UI of the summary? You can see like right now. And let's say if I want to click on a single issue to understand it more, what I get is a really cool in need report, it's really cool that, again, I have the URL where I can read more about the issues. Also, it's really nice that if I see that something is really stupid and it's a false positive, I can directly dismiss it. And if there is if this concrete issue is, how can I say, I know that it's a false positive, but my colleagues won't understand it, I can leave a comment. And also, that is in the case when you know that it's a false positive. But sometimes SAS can report for a really, really big vulnerability. So you can create an issue, and this will be seen from all of your colleagues. So something SAS differs from Precaution with that this is a UI feature, which means that when you click the dismiss vulnerability button, it doesn't eject a no-sec comment or something like this. GitLab will remember that this specific code is not vulnerable, and it will ignore it with its SAS tool. Configurations options are a strength of the SAS tool. It has a general configuration options. Again, you can exclude folders and files and so on. But it also has specific options for the tools underneath. And one example is the GitLab the Git leaks entropy level. Remember that I mentioned you about the entropy measurement. This is one place where you can place a border under which you know that you can ignore the vulnerabilities under a given border. And you can specify different concrete specialized options for the different tools, which is really neat, I think. And finally, let's compare the two tools. An obvious difference is the platform on the platform they're running on. GitHub and GitLab, the price is both free. And when we speak about supported languages, SAS has a big advantage here. Way of analyzing is a really interesting point of view, because on one hand, Precaution is really useful that it gives you results only for the pull request changed files. That means that you won't get a big report for your whole repository every single time. This will allow the contributors, the owner of the pull requests, to understand better that he injected himself a vulnerability. On the other hand, SAS gives you a report for the whole project, which gives the confidence of the team that at least we know that common security vulnerabilities are not in place in our code base. And configuration options, SAS has a big advantage here, as I mentioned you. And false positives, on one hand, it's really useful that SAS gives you the option to dismiss vulnerability in the UI itself. But imagine that you have the source code locally, and you run the same tool locally. The problem is that you will see the vulnerabilities you have dismissed on GitLab, but you will see them on your local machine, which is pretty annoying, I think. So it's a point of view again. And maybe key takeaways from this presentation. First, static code analysis tools or linters could be really useful for us. And I'm sure that some of you have encountered them. Some of you maybe have experience with them. And because there are a lot of false positives, some of you can be a little negative about them. But if they are configured correctly, they could be really useful. And I think that in the modern development, SAS static code analysis tools are a fundamental part of the security development lifecycle and the modern development as well. Also, security is part of every single product. Why I mentioned that? Security is not a luxury. Security is not something the user will pay after that. Security is not an add-on, an optional feature, an optional package. Security is expected. That means that we have to find different ways, different workflows to enforce security in our teams. we can't rely on the security engineers and threat modelings we can't rely only on this. We have to proactively work on the security education and tools for our development teams. Also, security linters could be really useful on a local level, but also they could be really useful for maintainers. And that shouldn't be ignored. Yeah, security linters by themselves, I mean the local ones are really useful for local development, but they're not so great for maintainers. And you can try out Precaution and SAS whenever you want. They're free to use, they will be free. I spoke with GitLab representatives and they assure me that for open source projects they are free. And yeah, so this is from me. Thank you for your attention. If you have questions about the presentation or anything else, I'll be glad to answer.
Hello, thanks for the presentation. Do you have any suggestions when working with legacy code, when you have like thousands of errors coming up, still use the linter tool somehow for the newly added code or something like that?
Yes, I think that I'm not expert to work with, to integrate those tools into legacy code bases. But what I think is the appropriate way to do it will be to start a linter with only a few rules enabled. So let's say there are specific rules which you know that are big problems. Start with them. Don't start with hard-coded passwords in the beginning, let's say, because hard-coded passwords lead to many findings. They're useful, but also if you just started a linter on an old code base, it will be like a Christmas tree. You will see so much data. So start with a few rules.
Other questions?
Thank you for your presentation. A question from my side. In your opinion, what is the best tool for JavaScript, standalone tool for JavaScript scanning?
It's a little complicated because I saw a good plugin for TSLint, but it was not ESLint. I don't know, have you used ESLint? So ESLint is really great, but it has so many rules that maybe it's good to disable some of them. So we can try out ESLint, and I know that there is a security module which will be integrated into ESLint. And something I read is that ESLint will support scanning both JavaScript and TypeScript in future. I'm not sure if that's the case right now. Isn't it so? Sorry.
Hi, you mentioned that false positives could be a nuisance. What's the situation with false negatives? Because that would be actual threat, right? What is your experience with those, basically? What's the percentage of false negatives that you get out of those tools?
I don't have an exact percentage, but it was really interesting to see that there were some false negatives for SQL injections. Because like, I've worked more on GoSec, the Golang linter, security linter, and I found out that some of the rules which it's using are not complete, let's say. There are limitations to the tool, but if you're using a commercial tool, you will get better support and more accurate results, that's for sure. And there is only, I didn't mention, but linters are not using only abstract syntax trees, but they're using data flow analysis and control flow, which are two paradigms, which are two things that are a little more complicated and most of the commercial tools are using. Open source tools are just starting to implement that, but are a little behind the commercial tools on that. So yeah, SQL injections, I saw that there were problems there.
Okay.
So no.
Hi. How those false positives are reflected on the pipeline automation once the code is committed? What's happening after that? How you could automatically deploy? Because if you have so many false positives, you are stopping somehow the automated process because you cannot validate all of them.
Security always stops the automation a little or more. And I know that the security, yeah. So one way is to configure what confidence level you want from your tool. So most of the linters provide you with a severity measurement and a confidence level. Confidence level most of the time is uses three variables: low, medium, or high. And if you have rules which are with confidence low or medium, let's say you can ignore them if you see that they generate a lot of false positives. Also, if you see a false positive for a particular rule really often, you can disable the rule as a whole, or you can change it. You can work with the developers on this.
Thanks. Makes sense.
I will be in the VMware booth. After that, also I have experience with scanning security, scanning Docker containers for security vulnerabilities, and cloud native stuff, other cloud native stuff. So if you want to speak with me, you can find me there.
Okay. Thank you, Martin.